Good. Okay, so hi, first of all, I'm Paolo, and I have a background in data-rich things. Things such as genomics and sequencing. So how I ended up contributing things to MPAI is an interesting interesting story, but I came to it from this angle. Let's say. Okay, so yeah, let's just move to the next one. Sorry, I'm a bit confused by the screen sharing because I cannot see. Okay.
Shall I use my slides? Okay.
I think I got it now, but just let me. Sorry, give me a second, otherwise then it will be a bit complicated. Yeah, I don't know how to. Okay. Maybe Leonardo, if you can share it, that would be great. Sorry, because I cannot, so it looks like it's difficult for me to go.
So please discontinue presentation. Okay, this is Paolo here. Right. I suppose you want the next.
Okay, thank you. Yeah, sure. Okay, so this essentially is the main conceptual scheme behind the architecture of MPAI standards, and I suppose you will have probably seen it before when EAF has been described, or we'll see it soon. I don't know how the order of presentations is. But just to summarize, so the main ideas is that there is an MPAI compliant controller, let's call it like this, so a device or other thing, which has suitable built-in capabilities that make sure that it can run MPAI sanctioned applications, so hardware, security, and so on. Then the controller runs workflows. Workflows, sorry, are made of are made of modules, and then all the components are provided by some entity which is called the MPAI store. So you should note that the design of EAF, again, which is a foundational standard that describes how to create MPAI applications, is intrinsically distributed. So we do need a place where components can be downloaded from at all times, but we'll just go into more details later on. I mean, the key point is, as Leonardo was saying before, we want modules to be interoperable. So we want applications to be split into smaller chunks, which are called modules, and those modules to be interoperable, which means that they should be sourced independently, have standardized interfaces, and communicate through them in order to build up more complex applications, right? And this we are doing because essentially what we want to have is like an open market of components with standardized functions and interfaces. So we would like to foster that so that essentially there can be a good competition in terms of performance. So that's why this kind of architecture came about. Next, please, Leonardo. Okay, so I mean, of course, standards are primarily defined to guarantee interoperability, right? That's what all standards do. But as we said, in this case, we are particularly concerned by interoperability in terms of a modular design of those modules, AI modules, AAMs, as so in MPAI parlance, and also workflows. So we adopt the definition of interoperability as the ability to replace the implementation of an AI workflow or module with a functionally equivalent implementation. And it's quite interesting because actually most of this standards, so this GME governance of the MPAI ecosystem standard was defined, actually really comes from this kind of seemingly simple statement. So, I mean, of course, interoperability is one thing, but MPAI is also concerned with offering trustworthy AI, which has become particularly, say, under the spotlight recently with applications such as ChatGPT and so on. So where things are starting to ask interesting questions about again how AI should be used and what are the limitations and problems. So we think that MPAI is in a sense really different in this respect because we do have an explicit, so we have built in this kind of considerations right from the start, and we have devised an explicit scheme to attach to implementations different levels of certification that describe how much they are compliant with the concept of trustworthy AI. So let's say there are those three interoperability levels. Level 1 are just private implementations. So someone just writes their own program, which is, let's say, formally compliant with the AIF standard, but no special guarantee is really offered as to how reliable its use will be. So the second level is more interesting. So those would be implementations that are also tested against the specification of a module, so of an AAM, and found to be compliant to it. So, but this is just technical compliance. So the component works. So the component should work as designed and could talk to other modules as stated. And of course, then one could just replace the component with a similar module implemented by someone else. But again, so the most interesting case are level 3 compliant components, because that means that not only the implementation is technically sound, but it has also, in a sense, been stress tested by an MPAI-appointed performance assessor. And it has been ranked against a number of criteria, so absence of bias and unfairness, how well the implementation operates when seeing input data that goes beyond what is present in its original training set, and all this kind of thing. So that is probably what really sets MPAI apart from other initiatives, because there is an explicit definition of what being trustworthy and having a good reliable performance is. So in principle, level 3 components are what an AI technology provider or end user can confidently use for the purposes that have been stated by their implementers. And MPAI has now certified that that is going to be the case. Next one, Leonardo, please. Okay, so what then are the foundations of the MPAI ecosystem? So again, so there are, of course, 3 different actors, 3 main entities that interact in the MPAI space. Those would be developers, integrators, and consumers. So, of course, I mean, that's pretty straightforward, right? So as the name say, developers develop AI components, integrators integrate them into more complex workflows, and consumers use those assembled workflows. However, of course, this is simple, but it immediately becomes clear that some facilitator is needed to orchestrate this, because this interaction will be complex. And in particular, we need some kind of impartial entity that, again, states and guarantees that different components developed by different developers or integrators are actually interoperable and trustworthy, and also that they are constantly available to anyone for use through an access that should be fair and equitable. And again, so as the original scheme that we saw, the drawing that was present in the first slide shows, the entity which is doing all this is a new entity specially created by MPAI for this purpose, which is called the MPAI store, right? Which is what we are going to talk in the next slides. Okay, so the MPAI store, as we said, has to do quite a few things to make sure that everything in the ecosystem works reliably. One of the most important design goals is that all implementations distributed by it are secure. So that is because, as we said, the foundational AAF standard, which again is the one that dictates how to actually implement MPAI compliant applications, states that the computation model is inherently distributed. So you cannot, of course, afford to have some malicious code to be injected into workflow because you have downloaded a component from somewhere unsound. I don't know, for instance, if you have a self-driving car or some AI tool designed to handle sensitive information, so you want all code to come from a reliable place, and of course that place would be the MPAI store. Then an implementation must possess some technical compliance, as we said, so it must do what it is supposed to do, communicate with other components properly, and pass, of course, some kind of lowest common denominator tests, we could say, designed by MPAI to weed out components that are not sufficiently good. So, and that's also, again, something that the MPAI store does. And finally, of course, we would like implementations to be high quality and trustworthy, as we said. So we have this definition of performance that we could call like the 4 pillars of wisdom of MPAI, so to speak. So first of all, the implementation must be reliable. So it must perform as stated and be consistent with its application scope, and we call this reliability. Then there is robustness, which means that the application should not behave in an unexpected way when presented with unexpected input. And again, this is particularly important, of course, with AI-based technologies, because they can produce unreliable output when the input is far away from their training set, or even when sometimes when the input, unfortunately, is close to the training set. Then third, performance assessment must be reproducible, and that's what we call replicability, which means that if we have assessed performance and there is a re-evaluation, of course, the two results must be consistent at different points in time and with different assessors. And finally, there should be fairness, which means that performance should not present bias or unexpected issues when operating within its stated scope, which, of course, as you know, is another big issue with technology, because there might be, usually there is some bias present in the training set. And again, of course, we would like this not to happen with applications with ethical implications, such as, you know, if you have an application that decides on visas or some medical insurance or whatever. Then, okay, the store does all this, and it also, in a sense, has a lot of tasks as a consequence. So it must, among other things, receive submissions of those implementations. In order to do that, also it must act as a registration authority, which means that whoever wants to implement standards has to get some code and identifier from the MPAI store first. Then, as we said, the store should verify that those implementations are secure, and this must be done well. Then implementations should be technically sound. Then, as we said, there could be external performance assessors who do quality assessments according to the 4 criteria that we defined before, and those results should be collected and stored and shown to everyone. And this is another of the functions of the store. And the store should also keep a catalog of the implementations that have been submitted so far, with proper metadata and indications about their quality level. And of course, there should be also a feedback and reputation part, as we can say, collected from users. On the top of that, so there are some technical, let's say, requirements that again, the store must provide components whenever requested by any workflow that needs them with the shortest possible delay, latency. For instance, again, if you're driving a car, so if there is a self-driving car and you need a component, that needs to be provided immediately. Then, so again, we should have this kind of licensing system that allows developers and integrators and end users to interact. And finally, some validation by cryptographic signature that the components are really actually what they claim to be, right? So there are lots of responsibilities in a sense. Next one, Leonardo, please. Next one. So yeah, again, this shows again what you have said. So first, there are, let's say, implementers that develop implementations according to what MPAI has decided is a standard. Next one, please. Can you go on, because it's, yes. Then there are performance assessors who assess this performance according to the 4 criteria. Then the store validates all this, checks conformance, technical conformance and performance. And then finally, once all of this is done through the store, a user can download the components and workflows. Okay, just one more, I think last slide, which is, well, this says what we just said in a more complex way. So can you please skip to the next one, Leonardo? Yeah, so just to clarify, the MPAI store is a not-for-profit entity, which is incorporated as a UK company, which is limited by guarantee without share capital. So that's, why is that not complete? Oh, okay. So you have an old version then. Okay, there were a few more things. So, okay, the store also acts as a technology incubator. So in that, of course, there are many things that can be done with MPAI technology. And again, the store will just develop possible right, that's it, thank you. Yes, so yeah, essentially it can explore, for instance, potential hardware embodiments of MPAI standards that might have commercial potential, and also there are other synergies, like, so it could explore and promote applications of MPAI compliant technologies with research grant applications. We just had one recently. It could do outreach, and again, in general, it could supplement MPAI's role as a technology provider, for instance, by developing reference software, versions of reference software, which might eventually lead to IP. And yeah, and that's so the space where we're moving in. And thank you for your attention.